Hello everyone, Siddharth this side, and today we will be solving another question on Geek for Geeks, which is median of two sorted arrays. So what we have to do in this problem, we have given two arrays and we have to return the median of the two sorted arrays. So let's first discuss the brute force method, and after that we will be discussing how we can solve this problem using efficient approach. So let's move on to the screen. So let's suppose we have given this array 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, and 13. So in the brute force method, what we will do, we will take two pointers as these two arrays are individually sorted. So we will compare these two elements and we will check which element is smaller. So obviously 7 is greater and 1 is smaller. So we will take this one and put into a new array. And after that we will move our pointer to the next element. Now again we will compare 2 with 7. So 2 is smaller than 7, so we will put 2 into a new array. After that we will move on to 3. So again 3 will come, then 4, then 5, then 7, then 8, then 9, then 10, then 11, then 12, and then 13. So this will going to be a merged array, and this is already sorted. Now what we have to do? Let's see what will be the size of this array. 1, 2, 3, 4, 5, 5 element in the first array, and 1, 2, 3, 4, 5, 6, 7 7 element in the second array. So total 12 elements in a uh, final merged array. Now for median, uh, if if you don't have idea what is median, so median is just the middle value if the number of elements are odd. So suppose 1, 2, 3. This is our array. So median will going to be 2 because half of our elements are on the left side and half of our elements are on the right side. So that will also that we will find using this also, like uh, the size of this array is 3 and 3 divided by 2 will going to be 1. We will take a float value. So one the element as a 1th index will going to be a median. But what in the case of even numbers or even number of elements, suppose we have 4 here, then we just have to take these two elements, which will going to be this 1 and 1 plus 1 another element. So second index. So in this case, we just have to return 2 plus 3 divided by 2. So this will going to be a median. So for odd case, we clearly can find the middle element, and for even case, we just have to add these two numbers. We just have to take average of these two numbers. So in this manner, we can easily able to find out the median of these two sorted arrays. And but the time complexity of this solution will going to be uh, big O of m plus n, and the space complexity will also going to be big O of m plus n. So now let's discuss the efficient approach. So second approach. In the second approach, what we will be doing, we will be using binary search. So in binary search, if you guys don't have idea what is binary search, so let me tell you. Suppose we have given this array 1, 2, 3, 4, and 5, and suppose we have to find 3. So first we will find the middle element of this array, which will going to be the length of this array is 5. So 0 plus 5, we call it low. If you have done binary search before, we call it low, and we call it high, which will going to be the length of the array. Now we will divide it by 2. So this will give us 2. So 0, 1, 2. So this is our middle element. So now we will compare this middle element to a target. So in this case, it is already equal. Suppose if it is 4, then what we will do? we will compare first 4 with 3, then we will check. Obviously this 4 is greater, so and the array is already sorted, so this element will uh, obviously will lie in the right part of our array. So what we will do, we will update our low to mid plus 1. So after that our low become this and high become this. Now we will again find our middle element and we will again compare. So and in this manner we will able to find out our target. So this is the approach that we will be using here also. So let's see how we can solve this problem. So let's take our previous array. So let's see how we can select it. So do it right. So can we remove it? Then we can move. Let's take. Okay, so 1, 2, 3, 4, and 5, 7, 8, 9, 10, 11, 12, and 13. So what we will do, we will partition these two arrays with respect to the smaller one. So let's see how we can partition these two arrays with respect to the smaller one. So smaller one of these two array is this. You will soon understand why we are partitioning the array using the smaller one, because uh, we have to minimize the time complexity. So we will partition these two array with respect to our first array. So what we will do, as what we will do in the binary search. So we will do partition x will going to be uh, 0 plus I, which is 5. Oh sorry, which is 5. So 0 plus 5 divided by 2, which will going to be 2. So we will partition our first array at second index, so 0, 1, 2. So now the elements in our first partition is 1, 2, and 3, 4, 5. Now we will partition this array with respect to partition our second array with respect to our first array, so that all the elements in the left partition should equals to the element at the right side. So for that we will be just using this simple formula. So partition x plus partition y should equals to the number of elements in our first array, which is, let's take that x, number of element in our second array plus 1 divided by 2. So now we have find a partition x, we just have to find the partition y. You will as we will try one or two test cases, you will soon understand why we are taking this formula, because using this formula we will correctly able to divide these two arrays in the equal parts. So the partition y will equals to this x plus y plus 1 divided by 2 minus partition of x. So this is our formula. So let's calculate using this formula. So x plus y plus 1. So x plus y plus 1 will will equals to the length of first array is 5, length of the second array 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. So 7 plus 1 divided by 2. So 7 plus 5 is equals to 12, and 13 divided by 2 will equals to 6. So minus partition of x. So which is partition of x is 2, so 4. So we will partition this array around the fourth index. So 0, 1, 2, 3, 4. So we will partition around 11. The number of element at left side will going to be 10, 7, 8, 9, 10, and 11, 12, and 13. Now you will clearly see the number of elements here are 6, and number of elements on the right side are also 6. So that's why we are using this formula. So now what we have to do, now we just have to take these 4 elements. Why we are taking these 4 elements? Because all the elements on the left side are already smaller. If all the elements, what we have to do, we have to minimize uh, all the element on the left hand side should be smaller than all the element on the right hand side. Why we are doing that? Suppose what a merged array will look like. Suppose take this array 1, 2, 3. Let's take our merged array 5, 7, 8, 9, 10, 11, 12, and 13. So for median, we just have to check the 4 elements in the middle, because these element will only decide what will going to be your median. So if we what we will do next, we will compare these two elements in the cross. Why we are comparing in the cross? Because this element is already smaller than this element. So if uh, if if you guys are getting idea what we are actually doing, we are just dividing these two array in the left part and right part, and the left part should containing all the element of the all the element all the left element of the merged array. So but we can't say which we can't say the order is going to be as same as our merged array, but this left partition will be containing all the element of the merged array, left all the left element of the merged array. Now what we will do, we will just compare this 2 with 11. So if this element is smaller than 11 and this element is smaller than 3, then we will reach to our condition. Uh, then we will reach to our condition where we have partitioned these two array in a corrected manner. Now what we have to do, the we just have to return the maximum of this and minimum of these two. If our if the length of our original if the length of these two arrays, by adding the length of these two arrays, the sum will equals to even number, then we will be having one element greater than right hand side. So what we have to do, mm, we just have to we have to take two elements. So we will take maximum of these two, because this is the left partition part. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4 elements here, 4 elements here, 1 here, 1 here. So see, 7 and 8 are our middle elements. So what we are comparing here, we want this 7 from our left partition, and we want 8 from our right partition. So in the left side, after comparing from all these elements, this element is the greatest. So we have to take maximum of these two. And on the right hand side, in all the elements from the right hand side, we have to take the minimum element. That's why we will taking minimum of these two. And after reaching to that condition, we will be having 7 here and we will be having 8 here. Now what we will do, we will add these two elements and we will take average of them. And in the odd condition, we will be having one element. In the odd condition, we will be having, in the even condition, we will be having same elements on both the sides. Sorry if I say, uh, I think I had said that in the even, if the length of these two arrays even, then we having one element greater. But sorry, the if the length of these two array is odd, then we will be having one element greater. So now in that case, what we have to do, uh, we will be having one element greater. So suppose we have 14 here also. Now the middle element will going to be this and this. I think 8 will going to be our middle elements. So we will be having 8 here. So we will be containing one more extra element which will going to be our median, and this element is the greatest in all of them. So what we have to do, we just have to take maximum of these last four elements. Now how will be defining these last four elements? So this element is the minimum of right hand side. So we will call it as minimum of left x, and this element is the maximum of left x. So this will going to be maximum of left x, and this element is minimum of left y, and this element is equal to maximum of left maximum of minimum of right y. So we have to consider these four elements, and we will be defining using same variable name uh, inner code also. So now let's move on to the screen where we will be coding this out. So if you haven't understand till now, as I will code it out, the code is really easy if you got the idea. If you will get the idea of this question, then coding part will be easy for you. So like now so first we will be partitioning in the coding. What we will be doing first we will be calculating the length of these two arrays, and we will be partitioning around the smaller array. So let's do that first. So first we have to partition our array around a smaller part. So first we will check if our nums2 if our nums1 is greater nums1 dot length is greater than nums2 dot length, then what we have to do, we have to return this method by just interchanging the position of our array, because we have to partition around smaller one. So we will be taking our first array as a smaller. So for if our second array is smaller, then we just have to reverse the order and we have to return this method again. So arrays, and we will be just interchanging the position, which will going to be nums2 and nums1. Now after this, what we will be doing, we will be calculating our low, which will going to be 0, and high will equal to, let's calculate the length also, otherwise code will become long. So length of our first array we will be taking as x. So nums1 dot length and int y, which will be our length of our second array, which will going to be nums2 dot length. Now we will initialize our high to x, as we are partitioning around first array. So now we just have to apply binary search. So while low is less than or equals to high, what we have to do, we have to assign those four elements, and they are max of left x, min of left x, min of left y, and max of right y. Min of right y. So these four elements we have to assign. So let's see. So while low, and we have to calculate our partition also. So for partition x will going to be our low, take a bracket here, low plus high divided by 2. So this will give us the index where we have to partition our first array. Now we have to calculate our partition y also. So for partition y, we just have to do, we have to use that formula, and that will going to be the length of our first array plus length of our second array plus 1 divided by 2. So minus partition x. So by using this formula, we will able to divide our full merged array into two equal parts, and after that what we have to do, we have to assign those four variables where min max of left x, min of left x, max of left y, and min of left y. So int maximum of left x, which will equals to, first we have to check for edge case if our partition x is equals to 0. So what I am saying, if our partition index of our first array uh, becomes 0, then we have no element left on the left hand side. Then what we have to do, and in the last what we have to do, we have to compare these two elements. So we have to take maximum of that. So we have to assign this as integer dot minimum value. If we assign this as integer dot maximum value, then we will get error as we can't compare these two elements. So for getting the maximum of these two, we have to assign this element as integer dot minimum value for edge case. So that condition will equals to, if partition of x becomes 0, then we will be returning, then we will be assigning our max left x to integer dot max value. Otherwise what we have to assign, nums1 partition x minus 1. Here it is. Okay. So why we are assigning partition x minus 1? Because where after partitioning this array, suppose in the first iteration, what will be the index? It will going to be 2. So we will be partitioning around the second index. So 0, 1, 2. We will be partitioning this array around second index. So we have to assign our max of left x to 2, which will going to be partition of x minus 1. So that's why we are assigning this to partition x minus 1. And after that what we have to do, we have to assign a min of left, min of right x, and this will going to be, we have to check our condition of our partition around x is equals to x. If this is the case, if all the elements are on the left side only, then we have no element here. So as we have to compare this element, as we have to compare our max min of left x and min of left y, and we have to take minimum of that, as I have told that we have in the left partition, the element which is of our interest will going to be the smallest one. So we have to take here the smallest of them. So we have to assign integer dot maximum value to it. So then we will compare these two elements here, the element here and the element at max min of right y. So after that what we will be doing, we will be assigning this to integer dot min value, which will going to be nums1 partition. Now you have understand why we are taking partition of okay. Now what we have to do, we have to assign for our y array as well, which will going to be max of left y, which will going to be, let's copy this out here, paste here. So partition y becomes 0 if our partition y becomes 0. We just have to update this to nums to partition y minus 1, and we have to do same for min of right y. Let's copy this out again. Okay, and after that what we have to do, let's change it to partition y, and here it is, partition y is equals to y here. Now after that, after assigning these 4 elements, we just have to check for our condition. So if our max of left x is smaller than, if our max of left x, where I have partition the array. So if our max of left x is smaller than this, and our max of left y is smaller than min of left x, then we have reached our condition. So if our max left x is less than or equals to min of right y, and then there is another condition, if our max of left y is less than min of right x, then what we have to do, we just have to and we have to check for another condition. If our length of our combined array, which will going to be x plus y, x, if our x plus y, let's take another bracket here again, x plus y divided by, modulo with 2 is equals to 0, then our length of these two arrays even, then what we have to do, we have to return middle two elements. So, and in that case what we have to return, as we have to return double as a data type. So let's take double here, double, take an equal bracket here again. So max dot max of, so on the left side which element we have to take maximum of, we have to take max of left x and max of left x and max of left y, and after that what we have to do, we have to sum with max dot min of max dot min of max of left, max dot min of max of, we have to take maximum of these two elements. So this is our min of left x. So min of left x and min of right y. So after doing this, we just have to divide this by 2. Okay, and in the else case, if the length of our array is odd, then we just have to return, let's take double first, double, math dot max of, we just have to take maximum of these two, which will going to be max of left x comma max of left y, and we don't have to take its average. And after this, what we have to do, we have to check for else condition. In the else condition, if else if in the else if our max of left x is greater than if our max of left x is greater than min of right y, in that case what we have to do, we have to move on the left side of our array. That's what we do in binary search. So we will update our high to partition x minus 1, and in the else part what we will do, we will update our low to partition x plus 1, and after doing this we will be returning -1 here if arrays are not sorted. So I think the code is looking fine now. Let's try to run this code. Okay, let's see here also what we have done. So partition x, okay, int. Now let's try to run it. Okay, what we have to do, then I find main of left x, main of, sorry, it should be right, main of right x and main of right y. Okay, now let's try to run. Okay, there is another mistake here. Okay, there is a typo, PRTITO. Okay, now let's try to run this code. Okay guys, so we have done mistake here. We just have interchange it. So this will going to be min value and this will going to be max value. And I had already told you why we are taking here min value, because if there is no element on the left hand side, then we have to compare this with the last element of left partitioned array, which is y array. So we have to take maximum of these two, because here if this is the element that we are interested in, then this will going to be the highest of all among all these elements. That's why we have to assign integer dot min value. Okay, now let's try to run this code. Okay, then again there is a problem. Partition by equals to by integer dot max value nums to partition by. Okay. Okay. Now let's try to run this code. Okay, so we have correctly solved this problem. So I think the main idea of this problem will going to be that if you have understood the idea behind this question, then the coding will going to be easy for this question. So I will say that if you want, you can watch this video again for getting the clear idea. So thank you, see you in the next video. Okay, let's submit it also. So thank you, see you in the next video, bye.